Hello viewers, welcome to Bhadra Academy. Once again we are here with the CUET undergraduate program video, where today we are going to discuss about the series and parallel connection of resistors, right? Also you can see our phone number, it is given in the screen itself. You can contact us about the different CUET programs, the courses, the fees, the structure and other details. So let's begin with our topic, that is series and parallel resistors, right? So to begin with, we can see the first we will take it as the series resistors, right? So resistors in series, and you can see the connections, that is in the sequential manner. The resistors are connected one by one, right? Where we are taking three resistors R1, R2 and R3. Also here another example we are seeing here, that is R1 and R2, that is a sample resistor which we will analyze here and derive the equation of it, right? So here we can see that the resistors are connected in series in the sequential manner in the similar line. So therefore if we connect it through a voltage source, right, so what will happen here? So the current will flow through both the resistors and this current will be equal and same, right? The same amount of current will flow through R1 resistor and R2 resistor, but yes, the voltage will be different because the voltage is V is equal to IR. So the current flowing there and the voltage across resistor 1 will be V into I and R1, and across the resistor R2 it will be V2, that is I into R2. Okay, so therefore such wise this the voltage will be divided but the current will be same, and therefore this is what it is mentioned here also, where two or more resistors are said to be connected in series when the same amount of current flows through the resistors, right? So in such circuits the voltage across each resistor is different, and therefore if any of the resistor is broken, if any line or resistor is faulty or it is broken, the whole connection is stopped, right? So the whole entire circuit is turned off, right? So therefore finally if we see that the equation that we will get, that is the equivalent resistance, both the resistance combined and equivalent resistance if we get, so that will be the summation of R1 and R2, that is R equivalent is equal to R1 plus R2, right? And if the number is increased, where we can see this number R1, R2, R3, and it is going to the n number of resistors, then the equation will become the summation of all the resistors that are connected here, right? So R equivalent will be R1 plus R2 plus R3 plus Rn, that is the n number of resistors. And the condition also you can see here, where the current is same across each resistor but the voltage across each resistor is divided. So this is all about the series connection of the resistors. Now the parallel connection of the resistors. So this is the connection diagram you can see, where each resistor is in parallel with the other resistor. So in this case we will see that the voltage is same across each resistor but the current will be divided across each resistor, right? So the voltage across each resistor will be same but the current will be different, and that will be given by I1, I2, I3, right? So similarly here also it will be mentioned in the same way, that two or more resistors are said to be connected in parallel when the voltage across the resistors are same, right? And the current is branched out, recombined when the branches meet at the common point. So, right, so again when the circuit is completed, so all the currents will again add up and it will complete the circuit current, right? So therefore, and here one thing is advantageous, if any of the connection or any of the resistor is broken out, right, so the circuit still remains same, the other elements are not affected, so other elements are remaining same, they are working properly. So if we see now the total equivalent resistor, if given for the two resistors, then it will be 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So this is the equivalent formula of the resistors connected in parallel. Now if there is n number of resistors, so then we can see that is 1 by R equivalent is equal to 1 by R1, 1 by R2, 1 by R3 and up to Rn, right? So this is the formula regarding the parallel resistors, right? So I hope that you have understood about the series and parallel connection of the resistors. So we'll bring similar videos for you, more and more videos for you. Be with us, contact on this number. Till then, thank you so much.